Hey guys, welcome to this tutorial. We are trying to create a linked list here, and we will try to see our own implementation of linked list, how to implement that. Okay, we'll try to learn in a very simple and easy fashion. Let's start linked list test. I'll add a public static void main. Okay, I will get rid of this to because and let me create a new class in linked list. The data will be stored as a node data structure, right? We all know. So what it contains is one is the value, that is the data, and one more is the node itself. Okay. The next pointer pointer to the next node. Simple. That class is done. So the next thing is we will create our own linked list class now. Linked list. I'll call this class as linked list. You can call it anything. Yeah. So this linked list contains again a node. It contains head node and a tail node. Okay. So the last node is called as a tail and the first node is called as head. Okay. So what we are going to do is we'll try to add some of the functionalities what linked list provides, like adding an element, removing an element, adding at the adding at the first index, adding at the specified index. So these are all the basic common minimum functionalities that we are going to implement now. Okay, let's start with the first implementation of adding a linked list, adding an element into linked list. Okay, we are just this takes integer and we are not specified anywhere generic types. We can go with the generic types also. That I will put it in the next video, like how do we generalize this concept. And if you see here, I'm not using any getters and setters. In the ideal world, you will have these classes created as an individual class, and it will have its own private methods and getters and setters. Okay, so right now we just wanted to learn the basics. That is the only intention. Okay, so now in this add method, we will say we will create a node, empty node object. Okay, we will just say node, new node. Okay, and this node dot data, whatever we received from the user, we are going to input. Okay, what is it problem? Node is equal to new node. Oh, okay, shit. Any problem here? Public void add. Okay. Complete the block statement. Here is the problem. Okay, let me clear. Node is equal to new node. You see, that was an Eclipse problem. Node.data is equal to the data. Okay, node dot next. Here we will initially set it to null. Okay, this is our bare minimum setup. Okay, then we will check is this a head element or what? Okay, if it is head element is not there. Okay, if head is equal to sorry, not 0, which is not right. Okay, head itself is null means this head node will be set to head. Okay, that's all. Next. Okay, how many minutes? It's fully charged. Remove this for simplicity. Okay. Next, what we are going to do is we are going to do something else portion. We have to traverse now this. We have to traverse to the linked list. Okay, and how do we traverse? We traverse same till there are elements, right? Element dot next not equal to null till the next current element will not having the null. That means it is not the last one. Okay, we are going till that. Then we'll say current is equal to current dot next. Okay, and to that current dot next, we just need to assign our node. That's all. This is as simple as that. Okay. Now let's add a method to display. Public void display or show. Let's use display. Okay. Here, what I'll do is, see, we have to traverse now. So these are the exact steps. Okay, which we have to do. We have to say the node, right? Current data. That's all. Now let's go to our test method. We'll create an object. LinkedList list is equal to new LinkedList list dot add 10 list dot add 20. Let's see what first thing, the node.next is head. Okay, the head will become the node. Let's see what is it is going to do. Just say let's start add it first. Why? Yes dot display. Let's see what will be the output. Oh, it worked. Earlier it was 10 and 20 and we had it displayed, and then we added it first and then we displayed. So that means it is working. Perfect. Okay, now let's see. We will add at a particular index. Okay, add at index. Okay, int index, comma, int data. What we are going to do is this is a standard. And see, this is my way of implementation. There could be better ways. Okay, this is just what I am using. Okay, if you have any better options, you should explore that. Okay, so here what I'm trying to do is I'm trying to keep it as simple as it is, because in order to for anybody who is just looking at this video, they should be able to get all those methods and they should be able to run it. Okay, and add index. So what we are going to check, if index is equal to 0, let's utilize already what we have written. Just do this, else. Okay, else. Now what we have to do again, traverse from head, but this time the traverse will be not on the the current dot next, because we have the index. We have to go through till that index -1, and we have to insert that, right? So instead of going through entire array and then inserting here, we are exactly going till where we want. Okay, again, current is equal to current dot next. Okay, so here what we have to do is, so the current dot next, right? So we are trying to insert one new element in between of the two existing elements. Okay, that's what we are trying to do. For that, what we have to do is we have to say our current dot next is there, right? That should be pointing to our node dot next. Okay, so our node dot next should point to current dot next. Am I right? Current dot next. We are trying to put it here, and then we will say this. Let's see whether it will work or not. Add that index and say 2 or 1 and say 3 or 33 and put. Then let's see whether is there a debug we need, or okay. Earlier it was 10, 20. We have added 5 in the beginning and then we displayed 1 here inserted. Yeah, this works perfectly. Good. Next, We have almost completed. Let's add a remove method. We'll see how do we try to remove an element. It is removal is based on the index, right? So I wanted to okay. So here I'll just say if index is equal to 0, that is the first index. If you are wanted to remove, we just need to shift that head element backwards, right? So for this, again, we have to do what? We have to do this. Really? How do I remove? Just imagine head is equal to, so your head dot next will point to head. That's all. I think let's okay. Let's see. Here, what I am trying to do is head will be there, right? If it is 0, if the index is 0, that means we are trying to remove the first head element. So in that case, head dot next, I'm trying to put it into head. I'm making this as head. Okay. Else what we are going to do is we have to again traverse. That's obvious. I'll use this. I'm very lazy typing, so please don't mind. Okay, we traversed till that element, and then let's use one more temporary variable to store the node. Okay, this temporary node I will put my current dot next. In my current dot next, I'm going to put it in this, and so and in this. So what I'm doing is this current dot next. Okay, it has gone till the last, right? The next element I am going to put it into the temporary. That means the next element is what we are trying to delete, right? So that next element data we are putting into temporary, and then temporary dot next I'm trying to put it back into the current element. That by doing that, I will get rid of the unwanted element. Let's start remove of 2. Okay, and let's start show. Come on. Not a show method. I haven't heard this. Let's see. Okay, we have the second element we removed. So second was 10th, and we have the removed. Yeah, that's all, guys. Let's recap once before winding it up. Okay, if you want, I will put this source code into GitHub, and if you want, you can take a look and you can improve your version of the code. Yeah. So first, what we did is this is my main test class. We'll come to it. I had a node data where I had 2 elements, int data and the node next. So the linked list I had a node as head, and I added one add function where I just defined a new node and I was checking whether if the head is good enough, then I will assign this node to the head itself. Okay, else. So else I will traverse through, and then at the last I'll add the element. So the current dot next. This node I will put it in current dot next. Okay, and then next add at first. Add at first again I'm going to initialize, and then I'm going to say node dot head. I'm going to point the head. I'm going to point to node dot next. The head I'm going to point to node dot next, and then I'll make the node as head. Okay, that's all. Then add at index. Again I'll initialize a new node, and I set this data. If index is 0, I'll call this add at first. Else only traverse will say current dot next. So the current dot next is I have iterated till here, and the next element I want the next element where we wanted to insert. Okay, that element current dot next I'll put it into node dot next, and this node I'm going to set it in current dot next. So that means after this element I'm going to put that element. Okay, remove. So remove is if it is index is 0, I'll just make the next head dot next as head. That means first element if I'm removing, I need a new head, right? So that the next element will become the head. Okay, next the node current is equal to this again traversing. I'm using the temporary variable, and I'm putting the current dot next into temporary, and then the temporary dot next I'm putting into current dot next, and then so. And I have a display method, a simple one, where I'm traversing and displaying the data via this current dot data. And if I execute this, this is the desired output. This is what we are expecting. Okay, thank you. If you have any doubts, queries, let me know, or else bye.